Question: define conservative field and prove that gravitational field G is a conservative field. Answer: conservative field. A conservative field is one in which the work done is independent of the path followed and the work done along a closed path is zero. W1 equals W2 equals W3. For a closed path, W equals 0. Gravitational field. The gravitational field is the region of space around the Earth in which it exerts a force of attraction on any body. Explanation. Let a mass m be moved from point A to point B along three different paths. Work done along path P1. W1 equals WA to C plus WC to B. For the segment A to C, the angle is 180 degrees, so WA to C equals F times D times cos 180 degrees equals minus mgh. For the segment C to B, the angle is 90 degrees, so WC to B equals 0. Therefore, W1 equals minus mgh. Equation 1. Work done along path P2. W2 equals WA to D plus WD to B. WA to D is 0 because the motion is horizontal. WD to B equals minus mgh. Therefore, W2 equals minus mgh. Equation 2. Work done along path P3. Divide the curved path into vertical segments named delta y1, delta y2, delta yn. Work in the first segment, W segment 1, equals minus mg times delta y1. Work in the second segment, W segment 2, equals minus mg times delta y2. Work in the third segment at the end of vertical height h, W segment 3, equals minus mgh. Equation 3. And so on up to W segment n equals minus mg times delta yn. Total work done. W total equals the sum of all segment works. W total equals W segment 1 plus W segment 2 plus W segment 3 plus W segment n. This equals minus mg multiplied by the sum of all vertical displacements, which is h. Therefore, W total equals minus mgh. Equation 3. Conclusion. Since the work done is the same,